What's up, guys? Today gonna do a video and show you how to convert this block logo phase 90 MXR pedal into not really the script logo from 74. I think right around 76 they changed, but it will get you close. It's not the exact same thing. One thing to note beside that is there's two versions. You got a revision E and a revision F. Mine happens to be the revision F. So that's the red board. We're gonna pull this out. Now you gotta be careful because these TRS 1/4 inch output and input jacks, they're threaded into plastic, so you don't want to over tighten them in any way or you're gonna fuck your input and output jacks up. So let's get to disassembling this and take a look at what we got to desolder. So for the knob, all we're gonna do is pull that off. Now I did turn it all the way down so I get the correct positioning of that. So when I remove this, there is a plastic piece that is put on there. So I want to note that the flat is on that side because we want to put everything together exactly the way we took it apart. You're gonna see you got a nut here and a washer here. We're gonna unscrew that, and then same thing with the foot switch, and then we'll get to the side of the TRS connections. Okay, so we got the board out, and I want to go over some stuff before we get into this. So looking over here at the circuit board, this is our output jack, and this resistor right here going across is your R28. Now, first and foremost, this is a double, it's soldered on the top and the bottom, so it's a through hole, but your trace goes from the other side to this side, so this is going to be a little difficult to get out. You're going to need some solder wick, and you're going to have to touch on the top and the bottom, and you're going to be careful not to overheat this. The next thing I want to talk about is the value of this. In circuit, it is 15.33K. Out of circuit, you can see here I wrote down red, yellow, black, red, and brown is the tolerance. So that equals 24K. That's the value of that R28 resistor with a 1% tolerance. Brown is your tolerance. Now, I'll show you on the ohm meter what it measures in circuit, but out of circuit, if you were to take this resistor out, is 24K. That brings me over to this toggle switch. It's a mini toggle switch, and I was surprised. I have this shit on hand, and this is all I have. So I got a double pole, double throw mini toggle switch. Now, essentially what it is two single pole double throw switches in one, because the left side is not connected to the right side if you do not run a jumper wire from here to here. If you ran a jumper from here to here, then these two would be connected. So just look at this switch as somebody put two single pole double throws in there. These are your common lugs, the center ones. The other thing to note about this is when the switch is flipped up, it's not connecting these two. It's actually connecting these two here, and I can demonstrate that in a moment. If you flipped it down, then it would be the opposite. It would connect these two. So let me show you the values in circuit, and then we'll show what the switch does. And then we'll move on to desoldering that resistor. If you're interested in doing this mod, like I said, StewMac has the kit. It was, reasonably priced. It was $8 and some change. They give you, you know, 2 pieces of wire. They give you the single pole double throw and some heat shrink. But you're still going to need soldering braid. And I mean, it's not really that great of a deal, because on Amazon you could get, you know, 6 of these switches for $6 something. But anyway, that's something to keep in mind. Let's get a shot of these values on the resistor in circuit. All right, so that's the values on in circuit. And like I said, if you took this out of circuit, it would be 24K. Okay, so if you can see there, I got the black lug right here, or the black probe on the center of the lug on the toggle, and that's up. Now, if we look over here at the ohm meter, you can see that shows open. Now, if we come down and we switch that, you noticed that was up. So in the up position, these two aren't connected. And then if we go ahead and touch that center lug. All right, so let's look over here again. Okay, so you can see that's connected. Now, if we were to touch the other side, you would get the same exact results. So I'm on the bottom side. Now we'll pan over, and you can see that. So the switch itself, you got one switch, but you can connect 2 different devices on this side to this side. So it's useful for guitars, you know, if you wanted to, you know, do split coil or whatever, you can hook one humbucker and the other. You could do all sorts of things. But anyway, for this, what we only need is one side. So all we're going to be doing is using the center lug and then one end lug, and then that will take that resistor in and out of this circuit so we can utilize it as it was from factory, or the way the script logo is in a loose term. I don't want to say it's exact because it's not. All right, so what I do want to mention here is these lugs. When you put the board back in, the distance from here to here is a bit high. So you're going to have to bend each lug slightly forward. And I recommend doing that before you solder any wires or put it in the box. Because what I did is I ended up cracking this piece off and I super glued it back together. All right, so you can see how I bent them. That's going to give us a little bit more clearance to get down towards those resistors. Okay, so right there you can see all I did is I touched the top and the bottom, and that sucked the solder out of that through hole. And let's see if, yeah, you can see that. Now we're going to have to bend this leg up. And let me turn it over and I'll show you on this side. So you can see all I did is touch that solder and it sucked it right out of there. And now you can understand what's going on. This is like, just think of it as a rivet with a hole in it. It goes from one side to the other side. All right, so what I want to tell you too is even after you desolder this, you want to take your soldering iron and you want to push it against that leg of that resistor and push it up until it's free, because you will have solder stuck from that leg of the resistor in that hole. Now we'll flip it over and gently lift that resistor up. All right, so it helps to have a pair of tweezers, and after you get that lifted out, all we're gonna do is bend that leg up, and you can see that says R28, so we got the right resistor. Okay, so what you can see is I just lifted this up. I left it full length. I re-tinned this part so we make sure we get a good solder joint. The other thing I did was I took a Q-tip with some flux cleaner and I cleaned both sides of the board because you don't want a short. So make sure that's good practice to do. And then as far as this white wire, all I did was tin it, and we're gonna go ahead and solder that, place it in there, solder it from the other side, and then we'll trim it that it's not too long, and then we'll attach the black wire over here, and then we'll put our heat shrink tubing over this resistor, and then we're going to mount that toggle switch over here. Alright, so you could see there what I'm talking about, that flux splatter. You want to make sure you clean that off with flux cleaner, and there's our wire. We're going to trim that down, and if you ever wanted to put this pedal back together, you would just desolder it from here and just reverse what I'm showing you. Okay, so you could see we got that soldered on. We'll slip the heat shrink over. We're going to go right from the bottom of the board, and we're going to go up to about maybe ½ inch past this solder joint. Alright, so we got our heat shrink on, and a little tip, I would not heat shrink this all the way down, because if you ever want to cut this off, you're going to have a hell of a time getting in there. I mean, you could use an X-Acto blade, but anyway, as long as this is heat shrink good up here, we're going to bend this wire over. You'll have enough clearance, as you can see, to get over these ceramic capacitors and get to the switch. Okay, so you could see all I did is take the black, put it to our common, and then the white to this slug. And if you notice, the switch is in the down position, so these two now are not connected. When you flip it up, that will put the resistor back into circuit. So up will be stock, down will be script logo type, because the resistor is taken out. The other thing I want to know is if you look at this wire, I ran it this way and then this one this way, and we'll trim these off. Again, you can see the splatter, hopefully, from the flux. You want to clean all that shit off there, and then it's time to drill a hole in the box. Alright, the other thing I just did before we mount this in the box is I put a little zip tie here to keep these wires contained, and then there's enough wire here to kind of loop around and, you know, finagle that in and then put the board in. The other thing I do want to mention, which I seen people say about adjusting this trim pot right above your potentiometer, don't do it. They have that set from the factory. It's not going to increase or decrease the speed or anything. That value, if your pedal is working, it's working. They have it set from the factory, and if you want to fuck your pedal up, go ahead and turn that. They have it set from the factory for all the components on here. So leave it alone, or you're going to have a fucked up pedal. Alright, so if you notice, I ran the wires on this side. Now, if you're using a single pole double throw, you're going to want the wires coming out the left, because when the switch is in the down position, it's actually putting the resistor into the circuit. When you put it up, which would be in the off position on the toggle switch, you're taking the resistor out and using the script logo. Alright, so now we get to laying where the toggle switch is gonna, there it is gonna get, we gotta drill a hole for that. Now, don't take my measurements exactly, because the diameter of mine may differ from yours. My diameter of the toggle switch is 227 thousandths, so I'm just going to mark it at 1/4 inch. It's close enough, and it'll give us a little leeway if we have to move it up, down, or sideways. The way I did this was I took the board. If you notice, this has a little keyway for the foot switch, so if you try and put it in reverse, you can't get it all the way in. And you got to be careful, because this pot here, it moves. All right, so you're relying on the foot switch, and you're gonna line that up. That right there is gonna give you this mark. and you should have equal space. So that's what we're looking for with the foot switch in there and the pot up there. We're looking for equal distance this way. Once you get that, we're going to measure from here to here. So that measurement right there is 1/4 inch, going from here back. Now going from here in, it measures 9/32. So what I did is I took a piece of tape, ran it across, and from this beveled part, I'm most sure you could see from here, I measured from here to here, and we're actually at 5/16 of an inch. So if we measure from there, you're at 5/16. So you want a 5/16 mark from there to the tape line, there to the tape line. What I did was I laid everything out and found the center of the hole here, and then I measured that 1/16 over, and I set the board to, you know, make sure that we're centered in the board. And then I measured from the top down to here to 5/16, and I measured that 1/4 inch for this cutout. You could see it on this side better. And then I measured the 1/4 inch from the edge of the board to the capacitor. And as you can see, this would be the 1/4 inch cutout, blocked out, and then I wrote cap, put a line there, and then I measured from that 1/16 over, and right in between here is 30 seconds. The other thing I did was I took a piece of masking tape and followed it up the center, and you could take your control and you can put that right about there, and then you could take your nut for your toggle switch and you can put that right there, and you could see the center in between those two lines is where we're gonna punch it and drill it, and that should do us. And then if that ends up with the little nipple there, you're just gonna have to either turn it to a flat or file it like I did. Oh, and don't forget your horizontal line here. You got to measure up that 3/32 and draw the line so you end up with an 1/8 inch space here, and that'll give you from here to here, and then from here to here where you got to drill your hole. Alright, so after you get the hole drilled, make sure you deburr this side and turn it around and deburr that. Also, you're gonna have a bunch of shit and shavings in here. Make sure you blow it all out, because I had a ton here and you don't want that getting your circuit board. Alright, so you can see all I did is take a piece of black tape and cover the IC chip and the resistors, mounted the toggle in there, and now we're going to put it all back together. Alright, so there you go. What happened here is you're going to have to file that corner just ever so slightly because it was dragging. Now it's not. There's enough clearance there, but there was some drag there. Alright, so for a small demonstration, I'm not playing nothing. I just want you to hear the difference between the down, which is the normal phase 90 in the block mode, now I'm going to switch it to the script mode. Welsh for you. Now that's the block way. Okay, here's the script. That's way more mellow, and I think that, you know, sounds good. It's definitely worth doing.